Sometimes you guys wonder about, we've talked all about these square roots and all about I. Is there a square root for I?
For -1?
Nope. You ready? It's the square root of 2 over 2 plus or minus the square root of 2 over 2 I.
Oh, well, I mean, that sums it up.
Yeah, pretty much. Now don't mock me and don't be rude. Now, yeah, you can. Here's the thing: you can get this guy, you can get this answer. Let me give you a little shout out to one of my peeps. The Mops Theorem. This is something that you will encounter in pre-cal or trig, and it's something that will allow you to take square roots and other higher indexed roots for numbers that can be quite complicated. And basically it turns this guy and looks at it from a trigonometric perspective. There's cosine and there's sine, and you would get something like this.
What extensions to this imaginary?
You know what? You might want to know this. I mean, that'd be pretty cool if I put that on a test, right?
No.
Here's a bonus. What's the square root of I? Well, it's got 2 square roots, Mr. Craig. It's there you go.
Hey, you should do it.
Okay, so how does that compute make sense? Is it just something that's like a...
How does it compute and make sense? That's a very good question. Take trig.
Okay, so you're not trying to teach us this right now?
Now I'm just showing you that there is a square root of I. In case any of you had that question, there is a square root, and that's what it looks like. It has 2 square roots. And those square roots are something that you would be able to calculate and compute if you were to take trig. How about this problem? I always like to give you guys difficult things. No takers on this one, I guess.
Can you do 3I with the Q, the right? Just, I know what I'm saying, but I don't.
I know what you're saying too, but
Did we add?
isn't that just -3?
Shut up.
Because
Hey,
Talking about that.
don't hate.
I tried. Okay.
I was about to say, I thought it would be I too.
We would think there would be I, but wait a minute. Where was the I coming from? Where did the I come from? What did I say? I came from what?
From
The negative?
No.
Imaginary part?
No. It came from the what? What did I just say? I came from the square root of -1. Is that a square root?
No.
Nope. It's cube root. Can I have negatives inside of the cube root?
Yes.
Most def, because I could say what to the third equals -27, and you guys could fill in the blank with -3. Don't forget what you already know. Just because I show you something new doesn't mean that it automatically applies to everything that we've done.
that explains my grade.
Got to watch out for that on the test, right?
Yes, thank you.
That's what I'm here for. So, what do we say the square root of -1 is?
I.
If the square root of -1 is I, then that means that I squared equals what?
-1.
I squared equals -1. Now I want to show you something about i's and their powers.
So does that mean that the square root of -1 is
Square root of -1 is I.
that theorem?
That theorem, I don't understand.
How's that?
Well,
The one you just showed?
yes, you could.
I'm just trying to go along with...
No, you're right. If I looked at -1 and I were to use Mops Theorem, I'd be able to come up with I, and I could look at it from a trigonometric perspective.
And apply the theorem.
It will work. I could even take something like 2 and talk about the square root, and it would still work out that way. Or I could talk about what is the cube root of 2. in a trigonometric, you know,
If
way.
it were applicable for this class, all we need to know is that square root of I.
This right here,
Square root of negative 1 is I.
this stuff right here is the key part. For what we're doing in this section right now, these two guys are key. These are crucial. You've got to know these. Now, I want us to run through the list of powers for the I so you can see what's going on. What's I to the first? I to the first is just I. What did we already say I squared equals?
Negative one.
What about I to the third?
Positive one?
Maybe positive one, but let's think about what it's made up of. It's made up of I squared times I to the first, right? I've got three factors of I. What is this I squared right here? What does that guy equal? We just said it was negative 1, didn't we? So negative 1 times I is negative I. If I had I to the fourth, I to the fourth is made up of I squared times I squared. So what is negative, or excuse me, what is I squared?
One, negative
Times
one.
what's I squared? So what does all that equal? Equals positive 1, right? This guy right here is so important to us to get to this part. Let me show you why. If I kept going here and I did I to the fifth, I to the fifth is made up of 4 factors of I times another factor of I, right? From here on out, we really want to focus on I to the fourth, because what is I to the fourth? 1. That means every 4 factors of I you have is equal to a factor of 1. So what is I to the fourth? Does that guy really matter in terms of multiplication? So I end up with just I to the first, which is just I. If I look at I to the sixth, how would I break that down?
I to the fifth.
Wait, what if you use I to the third and I to the...
It's not that useful. I could use I to the third and I squared to break this down, but it's not useful. I to the fourth is useful because what does I to the fourth equal? 1. Finding a factor of 1 is great. Like when you're trying to simplify a fraction, you're looking for the same factor. Like if they both have a factor of 5, what's 5 over 5? 1. A factor of 1 is great because you can take that out. So I to the fourth, does he matter? What does he equal?
1.
So what's 1 times I squared?
Negative 1.
You already know what I squared is, and that's negative 1. So what do you think about I to the seventh? How would you deconstruct this guy?
Is it going to start repeating itself?
And then you use I to the third. Nope.
Well, yeah, it's going to start repeating itself because I to the fourth is 1, and I already know what I to the third is. It's negative I.
Okay, so it's just starting to repeat itself.
And I to the eighth is going to be I to the fourth times I to the fourth, which is just what? Isn't 1 times 1 2? JK, it's just 1. Look at the pattern that you have here.
4 times
I, negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative I. Whoops, negative 1. I see I lost the pattern now.
So we can use
Delete
I
that.
8.
What?
We can use that one too, right? The 8.
Right, but what that allows me to do is to simplify something like this. I to the 23rd power. If I have 23 factors of I, how many sets of 4 factors of I do I have?
Yeah, 5.
I would have 5 sets of those guys with how many I's left over?
3.
3. Now, here's the reason I wrote it this way. What is I to the fourth?
1.
This guy is 1. What's 1 to the fifth?
5. Sorry, I'm sorry.
It's a good thing the microphone doesn't pick up everything. 1 to the fifth equals 1. 1 to the anything is equal to 1, right? So this guy equals 1, but what about I to the third?
Negative I.
The pattern that I saw tells me the answer is negative I. It's pretty cool, huh? You don't agree, you don't like that?
I just use my fingers.
You can, you know what? You may use your fingers. So I to the 174th power.
I'm not going gonna do it.
Oh, so you're not going to use your fingers on this one.
Not gonna do it.
What is important here? Is it important how many sets of 4 that I have?
You can go to 8, right?
Maybe that's it.
States of 8.
I don't want sets of 8. I really want to base it on sets of 4.
Okay.
But the sets of 4 doesn't matter because however many sets of 4 I have, every set of 4 factors of I gives me what?
1.
1. No matter how many ones I have, that doesn't matter. What does matter?
How many fours you have?
With
No.
What's left over. So what you need to do here is do some long division.
4.
4 goes into 174. 43 times, right? So how many sets of 4 eyes do I have? 43 with how many eyes left over? My remainder was 2, right? What's going to happen with I to the 4th to the 43rd? That just becomes 1, so it doesn't matter. So you're left with I squared, and I squared does equal -1. Maybe it would be good to have a problem or two like this on the test. Be some quick points as long as you know how to do division. Now some of you may have seen something like this before. A little baseball diamond. Right? Now, if you're on the Houston Astros team, you don't really see this very often. You don't really get to go that far around this if you do even get out there. Now, here's the thing. If you end up with something that's to the first power, you have an I. If you end up with the second power, that's -1. If you end up at the third power, that's -I. If you have a remainder of 0, you're back at home, right? So, hey, you actually scored a run. Sometimes you can score runs. Most of the time you strike out. Sometimes, you know, it's just the way things go, right? Of course, you guys aren't watching baseball because it's 162 games of boredom. Anyway, I'm sorry, I just lost a lot of subscribers. So if I look at this guy and I've got 23, if I go around 23 times, 1, 2, 3, 4, I go 23 bases. I'm going to end up right here at -1, at -I, excuse me.
You started from, if you start from 0.
But you're counting the bases. Like how many bases? If you go up to bat, that doesn't count as a base that you bet on, does it?
No.
You start counting at 1,
Okay.
and so on. So if I go around 23 times, or if I go to 23 bases, I'm going to end up right here. 174. Now here's the thing. Do the long division, because if I see somebody, and you know someone who doesn't pay attention is going to be doing this on the test, 1, 2, 3, 4, 5, 6, 7, 8, and you'll hear this, and you'll be like, just look at them. You know what? Just
Oh,
don't do that.
I just had a light bulb.